Whenever I talked about the blockchain, I usually like to use Demystified as a title. I think the blockchain and the decentralized apps or those industry, there's too many great marketing people, right? I think myself as a software engineer, sometimes when I read a lot of those marketing articles, I kind of like, what did I learn in my university? I understand all the English, but I don't understand what they're talking about. And some of them probably against what I believe and what I've learned. But the reality is blockchain technology is still computer science. There is nothing more than that. Let's first talk about what is blockchain trilemma. It's also called like impossible triangles, right? The most popular blockchain trilemma is about three major parts. One is scalability. The second is decentralization. The third is security. The trilemma basically means at most you can have two of them. It's not possible to have three of them. Right. I would like to give a little bit more details on what scalability, security, and decentralization really means in the blockchain. Right. Let's first talk about scalability. In the blockchain, basically I define the system can scale to handle more transactions simultaneously. So when we read all of those blockchain articles, we constantly hear about the TPS, and a lot of people talking about TPS without really knowing what exactly is TPS. For example, we all read the articles about Solana, that Solana's TPS is incredibly high. And we also hear somebody else say, hey, Solana's TPS is not that high because they're counting the TPS differently. For example, if you're using the simplest transaction, that is consume the least of the resource of a system. If you're only using this kind of a simplest transaction to test your system, you could get a higher TPS. However, if you're using some of the transactions, that is very complex. Apparently, you might get a much lower TPS. The second part is decentralization. Even though decentralization is one of the most important characters of a blockchain system, and it is also one of the most popular buzzword in this industry. I take this definition from from Vitalik's one of his blog talking about what the decentralization means. It means a system can run without any trusted dependencies on a small group of centralized actors. Usually in the blockchain world, when we're talking about decentralization, we are actually talking about a permissionless. Decentralization itself has a lot of meaning. For example, for AWS, Amazon Web Service, is a centralized service. We say it's a centralized service because AWS is running by Amazon, which is basically one party that Amazon can decide it to control the whole AWS. However, from the architect, from how they distribute all those computing resources, it's super decentralized. Right? It has many, many different availability zones. And in each of the availability zones, it has multiple different data centers. And your data is actually replicated in many different places. In the blockchain, what we're talking about decentralization is actually if it is permission or permissionless. The third part is security. Right? Security also has a lot of meanings. And in the blockchain trilemma, the security is about if the system can resist the attack from the nodes. When we talk about another, like a bank security system, is more about, hey, how vulnerable it is sustained by attacking from external hackers, people try to attacking from outside. And on the blockchain, when we talk about security, it's mostly talk about what if some of the node is not trustful? What if some of the node, the node itself, they're bad actors? And can the system sustain the attack if the node are trying to do something bad to the system. Right? In the Bitcoin, sometimes we heard about the concept called like a 51% attack. So the blockchain trilemma itself, this three parts. So once we have the kind of like a better definition, if we look at today's blockchains and we can mapping something, what exactly they are falling into. The Bitcoin, Ethereums, they're pretty secure and they have a pretty good decentralization. As we know, the system of Bitcoin only handles 7 transactions per second. Ethereum's performance is pretty bad. I think it's below 20. Even when the Ethereum just switched from the POW to POS, right now it doesn't really improve the performance. I believe in the future Ethereum performance might be better, but right now the Ethereum's kind of scalability, that's definitely is an issue. So I put the Bitcoin and Ethereum in the part of that. They have good security, good centralization, but the scalability going to be poor. So one of very popular blockchain recently is Solana. Apparently Solana achieved high performance. People attack Solana, basically say Solana is not that decentralized. From what I have seen in some of the outages in the Solana, see how the governance of blockchain. Basically what they do is they have to call each of the Solana's node runners to let them to reboot the system. This sounds to be not decentralized enough. Enterprise blockchain solutions or private blockchain solutions, it might fall into this kind of have a good security and good scalability, but decentralization part is the weak point. Is there a blockchain that is not secured but is scalable and have a very good decentralization? I don't believe any of the blockchain project we're going to claim that, okay, we are not secured, but we have very high scalability, good performance, and we are very decentralized, right? Probably nobody wants to admit that, right? I would say put traditional peer-to-peer network into this category. For example, like BitTorrents, it's all about the decentralization. Anybody can run the node. It's about the file sharing. The scalability could be very good. It's truly decentralized, permissionless. But from the secure part of view, it's definitely not designed for a security system. Some of government or civilian system, they try to put this kind of fake peer-to-peer network nodes into the system and then try to poison the whole system. It's really hard or even probably not doable if you just try to put some nodes to poison the Bitcoin network or Ethereum. From the Wikipedia, right, Trilemma is a word from the tree and the dilemma. It's also named as the impossible trinity or impossible trilemma or unholy trinity. When I do the research, I found the first time trilemma that is popularly discussed about is from the economic. That's called a Mundell trilemma. That was first appeared in around 1960s. Basically say in the international economic, you can only achieve two of these three of them. So one is the free capital flow. Another is the fixed foreign exchange rate. The third is like an independent monetary policy. Even though I'm not a professional in the economic, from this trilemma, it's easy to understand. It makes sense. For example, when I'm thinking about US dollars, right, compared to Chinese currency and also compared to Hong Kong currency, this makes sense to me. I'm thinking, is trilemma some kind of theory or just a kind of assumption? There are a lot of different places talking about those trilemmas. So there's many funny trilemmas I want to point out. For example, one of the is combination trilemmas. So basically say, hey, if you want to find a nice accommodation like a hotel, and you can only take like 2 of 3 of those kind of location, comfortable and affordable. You can only get 2 of them. It's really hard to get 3 of them. So for example, if I want to have a place that is have a great location and it's also affordable. For example, when I visit Europe, right, I want to stay in the city center. I want to really close to the fun places, and I do not want to pay like €1,000 per night. What do? There's a lot of B&B, there are hostels, which is very cheap. But does those kind of B&B and hostels, they have luxury beds and comfortable? No, you can't, right? You have to stay in a hostel. But if you want to stay in a great location and also very comfortable, you have to pay a lot of money to stay in those kind of star hotels, right? Sometimes you can find some kind of really nice vacation homes, also pretty cheap. But unfortunately, those locations are pretty distance away. Sometimes it's hard to get there. Is this a theory with scientific evidence? Probably not, but it makes sense to our everyday life. There's also some kind of very funny trilemmas like the jobs. The high pay, little work, and very close to home, right? Ideally, I want to get some job that is don't need to do anything and very relaxed, and I still get a very high pay, and it's very close to my home, so I can take care of my home and do not need to spend too much time. But does this even possible? Probably it's not possible, right? Where does the blockchain trilemma come from? I found a lot of the blockchain trilemmas, people are usually mixed them with a cap theorem. So cap theorem is a trilemma. That is also named the Brewer theorem. The cap theorem is the first appeared in about 1998, and it published as a paper 1999. Quite of some of the blockchain articles mix cap theorem with this blockchain trilemma. The cap theorem is mostly in the distributed system and especially distributed database. So the consistency is whenever you read something, if there's some write simultaneously at this other time, you will not going to read some data which is dirty. So this is a very hard problem to solve. The second part is availability. That's easy to understand. At the distributed system, every node or each of those nodes, you need to have a very high availability. The third part is partition tolerance. Partition tolerance in a easy to understand word is in a distributed system, there's a lot of those nodes. If some of those nodes are, when they communicate with each other, some of those messages are lost. Imagine, so there's network issues. And that part, I think that part can also count into some of those kind of nodes, or they're bad actors. They send a message which is incorrect. Those will not completely bring the system down. Today, when we talk about the blockchain, we talk about the consensus algorithm. Sometimes you heard about this word like BFT, PBFT. So what exactly consensus algorithm? The consensus algorithm is not something new. In the distributed system, there are many different nodes. How do those nodes agree with each other? So they need an algorithm to agree that they can reach the same agreement on certain things, right? That is consensus. So consensus algorithm exists for a very, very long time. For example, some popular consensus algorithm like a BFT is one of them. Another, probably a lot of people heard about it, is called Paxos. And there's also some kind of system called Raft, right? Talking about this is basically a lot of the blockchain concept. They're not new. They're not just a blockchain concept. They have existing in the distributed system for a very long time. Where is the blockchain in the cap theorem? Since blockchain is a distributed system, does blockchain actually fall into this cap theorem? The answer is yes. So the blockchain technology often sacrifices consistency for availability and the partition tolerance. When we use Bitcoins, we know that we need how many blocks information, right? For the Ethereum, it's the same thing. If somebody sends me some Ether, I need to wait at least 6 blocks to confirm. The blockchain system is a typical design called an eventually consistent model. That basically means the system in this kind of cap theorem, it sacrifices the consistency. Most of them are not immediately consistent. You have to wait for a certain time, waiting for a certain condition, eventually it becomes consistent. In the blockchain world, people invented a new word called finality. So people are talking about finality. What finality is? Finality basically means after some certain time, this blockchain system becomes consistent. Right? So some of the new blockchain, they have immediate finality, which basically means after one block, the system is going to be consistent. Right? Today, when people are talking about blockchain trilemma, most of them are talking about the performance. That is a scalability part. Is blockchain trilemma a theory or is that a limitation? I think that today's when we talk about the blockchain as a scalable, decentralization, and secure, I think this is more assumption. There is no theory or there is no scientific evidence say that you definitely cannot achieve it. It's a hard problem, but it's not something that you cannot achieve that. And today, why are we talking about this kind of a triangle problem? Why people even talking about this impossible triangle? It's because today's a lot of blockchain, their performance is so hard. And when the user complain, hey, why is performance so hard? People tell you, hey, there is an impossible triangle, right? I guarantee you secure. I guarantee you decentralized. So forget about complain about scalability because it's impossible, right? But I think this is not true. Maybe in the future somebody can prove, but right now I don't think there's anything that you can prove this can be true. There is totally possible some kind of blockchain can have pretty good decentralization, pretty good security, and also very good scalability. For example, Solana, even we talked about Solana is less decentralized, but compared to a database, compared to a bank system or AWS, it's still pretty decentralized. Disclaimer, I just make it up. I didn't find anybody talking about this because based on this kind of a mind model, it's very easy to find out like kind of 3 things that seem to be very hard to achieve. I put that like 3 parts. One part is security. And the second part is a rich feature that you can do a lot of stuff. The third is easy to develop. If we put this as a smart contract dilemma, we can easily categorize a bunch of things to here. For example, when we first talk about the Bitcoin script. Bitcoin script is actually pretty rich, feature rich. You can do a lot of things. A lot of things that people in the Ethereum industry, in Ethereum try to do, very complicated smart contract. Actually, Bitcoin already did that very long time with just a few lines of code. So Bitcoin script has a very smart design, and it intentionally not to be Turing complete. However, how to write a Bitcoin script, how to write a secure Bitcoin script is very tough. It's simple, but it's hard to develop. So when we look at the Ethereum Solidity, Solidity is basically a Turing complete language, and the EVM is basically like a virtual machine, can do a lot of things. So that means its feature, you can achieve nearly infinite use cases in the EVM, as long as you can write those code. The Solidity is a language similar to JavaScript. It's simple to develop. At least that is a goal they want to do, right? But is that secure? I would say a lot of those kind of Ethereum security issues, they are caused by the smart contract. In the early days, there's a problem in the language because Solidity is a very new language. The bugs, the problems in the Solidity itself actually cost a lot. A lot of DeFi attacks, they're because of the loopholes in the smart contract. I would say the security is always going to be a long-term problem. So is there the possibility that you can have a smart contract that is secure and also easy to develop? The answer is yes. The DSL-based smart contract can be easy to develop and also can have very good security. But usually when it's coming into the DSL, it's called domain specific. That means what it can do and what it cannot do has been written, has been clearly defined. So it's probably not that general purpose. I have some thoughts before I close this up. First of all, I think since blockchain is computer science, right? When we talk about computer science software, we talk about binary. But actually computer science and technology, they're actually non-binary. They have grayscales. When we talk about the design system, we're always talking about trade-off. It's not black or white. Is this system centralized or decentralized? There is no black or white. Say this is centralized, this is decentralized. Is hey, this system is linked to decentralized on this kind of factors. It might lean to more centralized on the other factors. There's nothing clearly to tell you this is centralized, this is decentralized. And also for the scale, what means scale? How much scale you want? Do you really need 1 million TPS or 10,000 is already good enough? This is always trade-offs. So the Trilemma problems, I think in certain degrees, as I mentioned, I think Trilemma problem is like model for we to solve problems, to think about the problem, to figure out what are the weak points or compare the product. Most of those trilemmas, they're not exactly computer science. And if you are develop something, you probably do not really limit to that. Just use your imaginations and probably you can solve that. And that's all for my talk.
I have a question actually. So if you go back to your very first trilemma triangle, and then where you kind of place the different blockchains, I'm wondering where ArcBlock would be on there. Or are you guys just not like in this?
So ArcBlock is more linked to the Solonas.
Okay.
We're sacrificed in exchange for better scalability and keep the security.
Okay.
Right.
Got it.
And also for our block smart contract part, we are on the DSL side. We do not have a Turing complete program language and do not have a VM that can do anything, but instead is a domain specific language that guarantees it's secure and also makes it easy to develop.
Okay. Awesome.
So whenever you pick something that's domain specific, does that automatically make it more, I would say, easy development on the secure side, like every single one of those?
It's not automatically. It's totally possible. So for those trilemmas, usually they say you can at most you can achieve 2 of them, but of course you can achieve 0 of them, or you can have a system only achieve 1 of them, none of the other 2. or you can achieve zero of them. It's always the trade-off. So when I say this is not binary, it's basically like you can have, imagine this kind of, if this kind of triangle exists, ideally you are positioning yourself on the center, but you can position anywhere. For example, some of use cases, let's say for a military system, they could be sacrificed, easy to develop, and also feature rich. They completely focus on the security, right? Because security is a key. I don't care, it takes a lot of time to develop. It's very hard to code, and I don't care, what else it can use. I only want this to be a nuclear button.
It's very hard to launch. You don't care how long it takes to make that development or how many buttons there are. You don't need a ton of different buttons. You need one button that says, launch the nuke, and you want it to be very secure.
Yeah, okay. So the Trilemma, I think, from a design system point of view, is more about this is the model for you to decide where to trade off.